Well, hello everyone, and welcome back to Adrian's Digital Basement. On today's video, we're going to be working on this machine here, and it's Atari 800 XL. And on a recent second channel video where I tested out a few Atari machines, this one here had a black screen. So it's time to start repairing this machine. So without further ado, let's get right to it. So taking a look at this machine, which has a good amount of yellowing on the side here and a very dirty keyboard that feels pretty gross to type on. If we flip this over, there's the note, 623, black screen. And interesting about this machine is there is no label on the bottom, and the plastic just seems, I don't know, kind of fake or whatever, but I don't think this actually is fake. I think it's just very oxidized and very yellow. In fact, check a look at the yellowing on the edge here, and that edge as well. And it's funny how the top cover isn't nearly as yellowed as the bottom. So perhaps the plastic that they used for the bottom cover was a little bit different. I think this keyboard is a mechanical type, and you can kind of tell that because you could see down there next to the keys, that brown color wouldn't be visible if this was purely a membrane keyboard. You wouldn't see that there. So let's see if I can even get this thing working. I'm pretty confident that I can, but you never know. Lately, I've had a lot of things sort of self-fix. I've also had a lot of things that I couldn't fix. So we'll see what happens with this one. What I will also do to this machine, and several people asked about this in the comment section of that second channel video, is I will do the mod on this 800 XL to enable the Chroma Luma output on it, the S video output. For whatever reason, Atari introduced Chroma Luma video on the first 800, which came out in '79, I think. So a long time before Commodore did with the 64, and they didn't include it on this machine. I don't know why, but oh yeah, look at this. I forgot. I did leave this thing disconnected because we did take a look inside of here. I have power connected, I have video output connected, and I just have the composite video cable connected right now. It incidentally uses the same cable as the VIC-20, so this is my little pigtail I made for that. This is my 800 S video or Chroma Luma adapter that I made. It outputs audio, Chroma, and Luma. If you use this on this machine or one that hasn't been modified, then all you get is the Luma signal. You get the audio and the Luma, so black and white picture, but the Chroma is not routed to this DIN connector. That's why you have no color. All right, so we're looking at the RetroTink here. Let's turn this on. There we go, we got a black screen. So it's doing exactly the same thing as it was before. I have the bench oscilloscope up and I have some schematics up. I found these online and they appear to be some recreations that look really good. I hope they're accurate because I think they're a lot nicer looking than the ones I've seen that are like scans from, I don't know, old Atari documentation. As is customary with machines that aren't working, that you don't really know much about, especially ones like this that just do a black screen, we need to start with some of the basics. Power, clock, and reset circuit. We have the CPU here on the schematics, 6502 Sally. I think there are some slight differences with the processor on this machine versus a normal 6502, so you can't just drop a regular 6502 into this machine. I might be mistaken about this, but this is the best of my recollection. So first off, VCC, pin 8 on Sally. That's where we need to look. Pin 1 VSS, that is ground, of course. Now on this board, this is the CPU right here, and it is marked with, well, someone wrote OK on it. Does that show up in the camera? Let me change inputs. If I get it at just the right angle, you can see that there's like an OK maybe written in pencil or something. So maybe someone has already been spending some time and effort trying to troubleshoot this computer. Well, even if that's the case, we definitely need to do this troubleshooting ourselves. So here we are on pin 8. Let me just rearrange these a little bit. We look at the RMS voltage on this pin. We are getting 5.04 volts. Pretty much figured that there's no problem with the power because I'm using a known good power supply. And actually, before I started this video, I tested the cable, like the video capture system, and the power supply with another working machine because I've been burned many a times where I had like a problem with the capture device or whatever, and I've, went down the wrong path. So testing first is a way to make sure that does not happen again. Anyways, the power switch is good, but we kind of knew that because we actually had the black screen show up there, but we are getting 5 volts, so excellent. Now on the 6502, when we're looking at the clock signal, you see here we have phi 0 on pin 37 and then phi 2 on pin 39. This is the input to the clock signal on the processor, and then it kind of outputs a clock signal that then goes to like other components on the system. In fact, here's like the ANTIC chip. That runs off the output of the clock. So we do need to check the input and the output, because if the output is broken, and it's possible it is, then other components on this system definitely rely on that signal and they won't work. So I'm on pin 37 here, which is the input, and we're getting a signal, which is a good sign here. And we're getting a really good looking signal on the pin 37, the input, and there it is, the clock speed, 1.78 megahertz. I don't remember exactly what the clock speed should be on the Atari, but I think that is roughly the correct speed. And here we are on pin 39, and phi 2 is looking really good as well. The same speed, like if the signal were distorted or missing or whatever, then that would be a problem, but it looks really good. Next up, we need to go to pin 40 here, which is the reset pin. And reset on the 6502 is active low. So when it's high, even though it's kind of noisy looking right here, I could probably zoom out a little bit, and yeah, it's just a bunch of noise, but it's up around 4.7 volts. That's fine. That means the processor is not in reset. Now if I turn the computer off, back on again, it stayed low for a second after I turned it on and then went high. So we know clock is good, we know reset is good, and we know the power is good. So that is not the problem. Next up, let's take a look on the processor here at the data bus and the address bus. I want to see if this processor is executing any code. That is really the next logical step for us to do to see if it's even trying to run anything. Now I'm going to switch over to one of my little clips here. This just makes probing these 40-pin dips a lot easier. And I recently used one of these on a video. People were asking me like, where did I get this? I don't even know if these are still made anymore. This one has a little bit of damage here, but it still totally works. I've had this and some other ones. I have a little like tray here with some other ones here that I find these at like vintage electronics stores, and I will buy them up because they're so useful for troubleshooting. You probably have to check eBay or check around surplus electronics stores, and then maybe you'll be able to find one. They sell them in all sorts of different sizes, and they're very useful. All right, the clip is on. Let's start taking a look at the data bus lines. I'm going to go to pin 26 here, D7, and there it is. And I mean, that looks like, you know, a system that's operating. I don't really know exactly how the Atari should look. I don't think I've ever troubleshot one that was not working, but turning it off and on, that looks normal. So I'm just going to quickly go through these, see if any of them look out of the ordinary. There's a little bit of this sort of low stuff going on, but I'm going to say that that might be okay. Maybe that means the bus is floating or something like that. I'm not 100% sure if the 6502 Sally here can float the data bus or not. Now let's start on the address line. So pin 9 is address line 0, and I'm going to do exactly the same thing. I'm just going to zip through all these until I find anything that looks out of the ordinary. (23). Okay, we have something that might be wrong. We're on pin 23, address line 13. Now there may not be a lot of activity on the particular address line. It's like high up in the address space. But look at this, when I power the computer off and on, that right there, that looks like attempted driving of that line. There, look at that. So I did a single shot. So we're getting max voltage of 1.98 volts. That is not enough. And I'm gonna say that that looks extremely suspect. So I just wrote down a little note here, pin 23, address line 13, 2 volts peak to peak. I accidentally wrote down pin 22, but I realized after counting that I am on 23. So let's go to pin 24. Oh, that looks wrong too. So we're getting 2.5 volts peak to peak on that one. I'm going to write this down as well. And then all we have left is pin 25, address line 15. I'm going to power cycle the computer, and that looks completely normal. So for the address lines, yeah, we definitely have those two lines that looked very, very suspect. Now there could be all sorts of things that cause that particular problem. Maybe we have the CPU, the drivers are bad on the CPU. But I'm thinking it is also quite possible that one of the custom ICs, I'm going to turn the power off, one of the custom ICs that's on those address lines is pulling the bus down. Could be a logic chip as well. We're going to have to go to the schematics and try to see exactly what's on those address lines. Incidentally, this IC right here is extremely hot. That is U7. Let's go to the schematic and see which one is U7. U8 was the CPU. U7, ANTIC. Okay, well maybe it gets hot. That could be completely normal. Now the ANTIC itself does have connections to the two lines, address line 13 and 14. So pins 19 and 18 are potentially issues. Looking at the GTIA though, it is only on address lines 0 through 4, so it is not on that bus. Let me keep looking around to see what else is on that bus. So this goes over to another page. All right, here's one of the ROM chips, and it's only on address line 13 and not 14, so we know that's not a problem. And this other ROM chip, the basic ROM, isn't on either of those, but the MMU chip is on 13 and 14. That is U3, which on the 800XL is this small little dip package right here. So I'm going to start drawing a little dot on things that have or could be suspicious because of this problem. So we know the CPU is suspicious, the ANTIC chip is suspicious, and let me keep looking to see what else is on the address lines. We have a 74LS158, that's a multiplexer, and that is there as well, pin 6 and 13. U27, that is U27, and what's cool is that is in a socket, so that means I could pull that out. We can kind of, well, I think my tactic is going to be identify everything that's on those lines and then remove them from the board and then see if that changes the behavior of those particular lines, and that should give us an idea of like what's causing that problem. Now the MMU chip, for instance, is not in a socket, so that'll be the last one I take out. And let's see what else here. The RAM itself we don't have to worry about because the multiplexer basically creates the address lines that goes to the RAM. So it's not the RAM and it's not this multiplexer. I just realized that this is a searchable PDF. So I can actually search for the address lines, like I put in A14, and we can see exactly where it is. So there's the ANTIC chip, there's the CPU itself, ANTIC again. Now we have the MMU, we already identified that. And we have the MUX, we identified that, and that's it. Okay, so we found everything that actually has that address line on it. That's address line 14. Oh, I might as well do 13 just to make sure. Although, honestly, whatever's causing the problem with 14 is certainly the same thing that's causing the problem with 13, because the problem is so similar. Therefore, it's kind of pointless to worry about a different chip causing 13 to be problematic. Case in point, the ROM that we already identified is on the A13 line, but not on A14. So I'm going to rule that out, at least for now. Okay, so that's everything. So let me summarize what I think could be the problem. So right off the bat, the CPU itself could be bad. Then the ANTIC could be bad, the MMU chip could be bad, or the MUX could be bad. I think it's got to be one of those chips. There's also another possibility that there's a problem with like a trace, or like the A14, A13 are shorted to ground, for instance, like somewhere there's like a solder blob or something like that on this board. Those are possibilities as well. But I think the first thing to do is let's start popping these chips out of the board, and I'm just going to do it one by one. We'll start with the MUX, and of course, pulling the MUX out will create a completely non-working system, but we just want to see if the address line returns to normal when that chip is out of the board. Okay, I'm on address line 13, pin 23. Let's turn on the computer. No change. So it is not this MUX chip here. Pop this back in the board. You know what's bad is that all the chips that are left are custom chips. Therefore, if one of them is bad, well, that's a problem. Because ANTIC gets so hot, I'm going to pull that one out next. All right, I just pulled the ANTIC chip out of the board, and okay, so we have a completely non-working system at this point, which might be completely normal. Let me just check one of the other address lines. Could be like the 64, like that the ANTIC chip actually generates the clock and stuff. So I have a feeling that's actually the case. So pulling this out, that's clearly not going to result in a working system. And the only real way for me to test if that's the problem is to get a different one out of another working system. So with the computer, wait, oh, I'm on, I was like, wait, the signal's good. I put it on a regular random address line. And no, definitely this address line is still bad. Okay, so we're going to go back on 23. And I'm going to bend out the pin on ANTIC so it will not have a connection to that particular pin anymore. So there's ANTIC, and we're looking for 13, so that's pin 18. So I just bent out pin 18, and I make sure the power is off. It is. And let's pop this back into the socket here. Alrighty, here we go. What are we going to see? Ah, look, normal activity. That's a bad sign, everyone. That means that the ANTIC chip is the problem. Okay, so now I'm on the address line, or I'm on pin 24, address line 14. It's interesting. Do you see that? How there's like some normal activity just there, and then it's clamped down. So I'm going to pop out the ANTIC again, and we're going to bend out the other address line there. Obviously, this will create a non-working system. I mean, it's already non-working, but it will definitely be non-working with these pins bent out. So we're going to be bending out pin 19 here. And the ANTIC chip is back in, and there it is. Completely normal activity now. Well, now it went high, but that just could be because the processor is quite unhappy. But that is all normal, and now it's just stuck high, and you can ignore the fact that it's not really going low. That's just the computer halted or whatever. The fact is, both of these lines now have what looks like completely normal activity. Yep. So at this point, my hunch is that the ANTIC chip is the problem. So all I can do is open up another one of my Ataris, and we're going to take the ANTIC chip out, and we'll see if that indeed fixes this machine. All right, here's an ANTIC chip I took out of another working machine, and as you can see, I stuck heat sinks on it because I guess it gets warm. So I'll make sure the power is off. I'll pop the clip off there, stick that in there. And the question is, actually I shouldn't have popped the clip off before we even hook up the video. Let's take a look at those lines now to see if that activity we saw, maybe that was totally normal, I don't know. Okay, as in the correct way, just double checking. And here we go. There we go. So we are on pin 23, and that looks completely fine. And pin 24, that looks completely fine as well. So I think for sure we have identified that the ANTIC chip on this machine is definitely bad. At the minimum, that's what's going on. So let's see, do we have a working machine? Here we go. There we go. I mean, why is it purple? Color looks completely wrong. That's so weird. But the system is working, so it's freaking working. But it's purple. That doesn't make any sense. Is there a way to adjust the phase or the color phase on this machine? That is hilarious. Well, I just noticed there is this right here. And that actually, well, potentially adjusts the color carrier oscillator. So let's say if turning that actually fixes the color problem. I'm going to get a non-metallic screwdriver here, and we're going to turn this. Oh yeah, there we go. That is exactly what I thought it was, the color phase. So I've been looking at the schematic to try to figure out exactly what this potentiometer does, R38, and if we zoom out here, it's that potentiometer I just adjusted, and that does seem to go into the CPU. So 5 volts goes through this little circuit right here, a couple transistors, and there it is, into Phi 1. So remember when I was talking about the clock, actually that's the one I should have been looking at, not Phi 0, which seems to be the one that's generated from the ANTIC, I think. Yep. Comes from the ANTIC. So Phi 1 comes in, and I think what comes out is Phi 2, and then that goes into the ANTIC, and then out of the ANTIC, that comes Phi 0, which I think is what the CPU runs off of, which is why when we took the ANTIC out, we didn't have a working system at all. I figure the people that know a lot about Atari 800s can comment down below about how this little circuit actually works, and what we should actually have this oscillator adjusted to. I don't think it necessarily matters. I do know that the color on the Atari should look more like this. At least that's the way my other Ataris look. The reality is it doesn't affect the system in any kind of negative way to have it off a little bit. It's just that your program may not look exactly like you expect it to look. Now that the system is working, the CPU gets very, very warm. ANTIC is getting warm, although with these 3 heat sinks on here, not that hot. That chip doesn't, oh, that chip gets warm too. Not hot, but warm-ish. And these ones, yeah, they're kind of warm, but not that bad. Anyhow, we have a working system now, so that's really cool. I'm glad I was able to figure that out. It does suck though, that's this custom chip here, this ANTIC chip. There's the markings on it in case anyone is interested. Maybe specific ones like to fail a lot or whatever, but this one is bad. Now the system's working, let's modify it so we can get that Luma Chroma output on it. So we're on the schematic on the correct part here. So we have monitor out, that's the Luma signal, and then we have the video signal, that's composite video. What's missing on the connector, which is the video connector right here, is that Chroma signal. So if we take a look at the schematic right here, we have color, and there's all this color circuitry here that generates the color signal. And then it comes out right here, and then it goes through a 75 ohm resistor through a capacitor and is combined to create the composite video. So if you lift this capacitor, you remove this capacitor C54, it creates, well, monochrome video on the composite jack as well. But I think that has the effect of improving the Luma Chroma. But that's, of course, once we even get that working. So if we look at this little junction right here between the 75 ohm and the 3K, let's look at where the other one goes. This C55 comes up here, and oh right, that's right. This goes over to the RF modulator. So I think what we need to do is we just need to locate this point here, either R68 or 67, because we're going to pick up right here, or we can pick up right here, which is on one side of R66. That should all be chroma signal. And then we're going to have to run that to the video connector, and we're going to have to look up the pinout on there, and hopefully on the top side of the board here, we could just solder it onto the appropriate pin, but it might well be that we got to take the board out of here and do it on the underside. So first off, let's see if we can find the particular video signal we're looking for. So R68 and 67, we're looking for the chroma signal. So I have the scope here. Now, one of the issues is with the Atari, and the BBC Micro is the same, is that there are silkscreen markings on here, but they're underneath the components, and therefore you can't really read them. So that's not helpful at all. Let me dig around and look to see if I can see that particular part or where those R67 and 68 is, so we can figure out where to pick up. Alrighty, after looking around, this is R67 and 68 right here, these two resistors. And remember, we're looking for the point where they're common together. So I have the multimeter on continuity mode, and let's see about this side. Nope. How about on this side? Yep, 0 ohms. Okay. Let's use the scope with this computer turned on. Where's the probe? And let's see how that looks. Okay, that is definitely a chroma signal right there. And yeah, both points are going to be the same. So that is the chroma pickup point. We're going to take the signal from there and we're going to run it to the video connector right here. And let me figure out which pin is the correct pin for the Atari 800. And there we go, it is pin 5. Now, one thing to keep in mind is the 5-pin Commodore connector, like on the VIC-20 in the early 64s, pin 5 I think has 12 volts on it. So you do not want to send 12 volts into your monitor. Bad, and that's why it says danger on this particular picture. But anyways, pin 5 is what we're looking for, and I'm turning off the power, and I just need to figure out which pin that is and if we can get to it on this side of the board. And no, you cannot. At least on this one, the pins are visible there. Pin 5 is there, but it's shrouded in plastic. So I think the best thing to do is to just take this board out. And is this even screwed in? Yes, there's a screw right there. Let's get that out of there. And to get this board out is always a bit tricky just because the connectors and stuff are in here. You kind of got to bend the case a little bit. There we go. All right, looking on the back side of the board, we can see very clearly which is pin 5, the one that's not connected. It's that one right there. And now all you got to do is run a little bodge wire from that pin there to the union of those resistors, which when you're looking at the back of the board, you just follow this grounding plane here. It's right there. And there we have it. I just put a little Kapton tape to hold it down, and I actually ran it along the ground plane right here, so it's mostly shielded, so to speak. So yeah, the color signal just runs there, right to the union there. I did read something online as well that there's a capacitor right here, C56, and if your machine has that, you should remove it. Just cut it out entirely. Apparently, it softens the video picture dramatically. This machine, obviously, it doesn't have it installed, and on the schematics we were looking at earlier, it's not on there either. So whoever created those schematics didn't even put that in. But supposedly it's there on some machines, and it results in very soft image quality. All right, so we need to do some testing on this machine because we don't really know if it works. So first I need to try to get this back into the case, which is always a little annoying. There we go. That wasn't, it's harder to get out than it is to put back in for some reason. Incidentally, this thing says it's a Rev C board right here. So That might mean something to the right people. That doesn't mean anything to me because I don't know anything about Ataris. Okay, so let's just check to make sure the composite video still works and the computer's still working. Yes, it is. Should get the basic prompt. There we go. And I have my Atari 800 Luma Chroma video cable connected up. Let's switch the input on this and exit out of there and turn this on. Do we have working picture? I might have the cables reversed. I think they're reversed. Let me just swap them around. Yep, there we go. And the brightness there, that's a RetroTink thing. So it should fix itself after a second. And yes, it does. Now I gotta say that looks really good. Without that mod, we'd have a black and white image here. Now I do notice the ever so slightest jail bars visible. That is specifically because of the way the circuit combines the chroma and the luma for the composite video. It creates that artifact. The fix apparently is to just remove C54 from the board, which is, well, somewhere on there. I'm not gonna do it on this machine. And that will make monochrome composite video, but get rid of those artifacts. So that's something that you can choose to do, or potentially lift one side of this and wire it to a switch or something. You have to like drill a hole in your case to put a switch. But if you wanna get the best possible quality on the 800XL, that's the trick. Lift C54, remove that C56 if you have it, and run that wire to the Chroma Luma jack, and then use a cable like I just did to hook it up to S-Video, and it looks great. Alrighty, we have the keyboard here. Let's hook this up, see if we have an actual functional system. All right, I think that is connected properly. I'm just spilling stuff all over my workbench here. Alrighty, let's see. Will we have a working system with a keyboard that works? Because I'm kind of half expecting this keyboard is not going to work at all. All right, there we go. Power this on. Hopefully everything is still working. Yes, it is. Hello there. O is not working super great. Hello there. I have to look around the camera. Hey, that's not bad. How about reset? That works. I think we can hold down Option and we can, there we go. We are in self-test. Okay, we hit select to pick audio, video, visual, hit start. Nice. So that's testing the, is it the Pokey chip? Oh shoot, I forget all my Atari chips. I apologize to the Atari fans. The sound chip has 3 voices. And it's working, and I think there's gonna be a noise channel. No, 4 voices. Boy, it's the SID that's got 3. This should have plus a noise. Oh, it doesn't play the noise. I think it does have a noise channel. I'm completely messing up everything to do with Atari right now. So 4 channels, I think there's noise. I thought that's a separate channel, but maybe not. So we can exit for pushing help. So we have working sound. Let's see about the keyboard here. Okay, so we can go through the keys here. Okay, so most of the keys are working. There's like a couple that are problematic, but obviously as I just type some more, it's working better. And this keyboard could probably just use like a full disassembly, deep cleaning, and maybe a little contact cleaner in those contacts if these are stack pull type switches. And then, yeah, it's gonna work pretty well. It doesn't feel terrible like the way it feels to type on. I have some other Atari 800XLs that have a terrible keyboard where like if you push on the edge of the key, it binds really bad. This one does not do that. I can push on the edges of the keys and it feels totally fine. We're gonna run the memory test here, and this is gonna test all 64 kilobytes that are in this machine. A lot like any other 64 kilobyte machine that's a 6502, it's gotta use some bank switching. So I think it's 48 kilobytes, that is the main memory, and then that extra 60 or 16K at the top ends up being bank switched in. And I'm pretty sure that's how like the RAM expansions for the 800 work, because there are things that can go up to like maybe even megabytes of memory on this thing, and it just extends the bank switching functionality for that top little extra piece of memory. What's interesting is one of the things that people say is not as good on the 800XL versus the 800 is this doesn't have 4 joystick ports on it. It only has 2. But I think what Atari did is they used some of those extra I/O lines that were used for those additional joystick ports to implement the RAM banking, and it's that MMU chip in there that makes it possible. I think, kind of recall reading that. I gotta say, watching this run, that it goes pretty slowly. Oh, it's finished. Okay, well, I was thinking that there would be 64 little boxes, because 2 rows is 32, but for whatever reason, there's that many boxes and it's finished. And now it's testing the RAM again. So this machine appears to be working perfectly. So with this machine working, I think this calls for a game. Let's try a Pac-Man cartridge, see if this thing is truly fully functional. So power off the computer first, of course, and we're gonna make it so the label faces towards me. And left cartridge powered on. I have my joystick here. Well, it's a gamepad. And we're gonna hit start. I don't know if I'm in the right joystick port. We'll find out shortly. We are indeed, and the joystick's working. So yeah, this computer, I mean, I haven't done a full test on it because I don't have something like a dead test or a diagnostic harness, but clearly we have functional games. That's a pretty good implementation of Miss Pac-Man, I gotta say. And I just got eaten by a ghost. Well, there we go. A successful repair of an Atari 800 XL. My first of such machines on the channel that I've ever had to fix. It's unfortunate that it was the ANTIC chip that was bad because, of course, well, these are the custom chip, the heart of this machine. And without it, well, it's not going to work at all, as we saw. But we were able to see that those address lines were being pulled low by this bad chip right here. And luckily it was in the socket because we were able to bend those 2 pins out to validate that it was the ANTIC chip. Now I took out that MUX chip. It's too bad it wasn't that, because if that had gone bad, and those have gone bad on 64s plenty of times, I could have got a spare part and put that in there, and then, well, this machine would be working without having to worry about something like this. If for some reason you have a machine that has these chips soldered onto the motherboard, all of them, I don't know if that's the case on some of these, then what you can do is I could have clipped the pins off on this chip, well, gone through all the other chips as well, like clip the pin on the MUX, no change, solder it back together, clip the pin on this one. Oh, that made a change. Well, that would tell us it's this chip, but you kind of go through all the various chips until you find which one is the culprit. And of course, if I didn't find any that were the culprit, could easily be the CPU itself that was bad. And beyond that, it could also be the short on the motherboard or something like that. That's an extreme edge case, but if this machine had been worked on previously, like I saw bodge wires and stuff, well, then that's much more of a possibility. But this computer didn't look like anyone really did much to it other than that okay writing that was on the CPU. So anyways, if you liked this video, I'd appreciate a thumbs up. If you didn't, you know what to do. Huge thanks to my patrons. Their names are scrolling beside the screen. They literally make this channel possible now. So they're rock stars, and I really, really appreciate the support my patrons give me. So once again, yes, thank you very much to them. Comment down below. I'm sure my Atari fans are going to have lots to say about this repair, maybe about the failure proneness of this chip. Is it something that commonly goes bad, and other stuff like that? Oh, and then also I modified for S-Video. So that's kind of cool. If you have an 800 XL, I highly recommend you do that mod, because you can see the picture quality was really, really good once this thing was modified that way. So I guess that's going to be that. So stay healthy, stay safe. I will see you next time. Bye.